Formula for calculating CFSE in octahedral complexes. CFSE is the crystal field stabilization energy. Stability is associated with lower energy. When the energy is lower, the element or the compound or whatever, it will be more stable. So in an octahedral complex, we need to have certain things in our mind, or we need to find out certain things about that compound. Whether the ligand approaching is a weak field ligand, or the complex is high spin complex or low spin complex, and the delta O is less than the pairing energy, etc. We have to have knowledge of for calculating the crystal field stabilization energy. We are familiar with this diagram. The 5 d orbitals, they are degenerate, that is, they are having the same energy. Ligand approaches, there is an increased energy, and then they split into two sets, that is the EG set and the T2G set. EG set having higher energy and the T2G set having lower energy. The dxy, dy dx set belong to the T2G group, and the dx square minus y square dz square belong to the EG group. Now this line is called the barycenter. It is having a 0 value associated with it. The quantities above it is positive and the ones below it is negative. And this delta O is the crystal field splitting energy, that is the energy difference between the EG and T2G sets, that is delta O. If an electron has to go from this orbital to a higher orbital, it has to make a big jump from here to there. So if this separation energy is large, that electron will not be able to go there. It will remain here only. That is, there is another factor called pairing energy, which makes the electrons pair up in the given orbitals. So that is how we say if a complex is high spin or low spin. If there are too many unpaired electrons in orbitals, then we call it a high spin because the electrons are not paired. But if the electrons are paired, then there will be lesser spin. Now we have to calculate the CFSE or crystal field stabilization energy for a weak field ligand, that is a high spin complex. Too many unpaired electrons in it. That is, delta O is less than the pairing energy. Pairing energy is too much. Too much energy has to be put in order to pair up the electrons. And delta O, that is, the electron can go from one level to the other. So let us see what is the formula for calculating crystal field stabilizing energy in an octahedral complex. So that is CFSE equals minus 0.4 of delta O into X. Let us take X as the number of electrons in the T2G set plus 0.6 delta O into Y, where Y is the number of electrons in the EG set. Here it is. We can take this as minus 0.4 X plus 0.6 Y into delta O. So this is the formula for calculating CFSE or the crystal field stabilization energy, that is minus 0.4x plus 0.6y the whole into delta O, where we can write that x equals number of electrons in the T2G set and y equals number of electrons in the EG set. Suppose we are asked to calculate the CFSE in a D3 complex. That is, let us draw the d orbital. 3 electrons in it, and they are going to a higher level of EG, and here T2G, where the 3 electrons are coming here, 1, 2, 3. Now, according to the formula, CFSE equals minus 0.4 into x. X is the number of electrons in the T2G set. There are 1, 2, 3 electrons. 3 plus 0.6 into number of electrons in the EG set. There are no electrons, so 0 electrons into delta O. That is equal to minus 1.2 plus this is 0 delta O equals minus 1.2 delta O. Here there is no pairing happening, so we need not consider P, that is the pairing energy. Otherwise we will have to put a P, that is CFSE equals minus 0.4 delta O x plus 0.6 delta O y, that is minus 0.4 x plus 0.6 y into delta O plus P, if there is pairing energy or pairing taking place. So there is no pairing taking place here, so we need not consider it. So minus 1.2 delta O is the crystal field stabilization energy for this D3 complex.